Okay.
Only way I can do that.
For our Physics 2 final project, we decided to take an etch-a-sketch and incorporate a joystick into its function.
Using the Arduino microcontroller chip.
Indeed.
So essentially how this works is we have an old simple board that just has some push buttons in from an old joystick, and each push button corresponds to our input that we send in to our Arduino board over here. Each signal from the joystick, each button comes into a different pin on the Arduino board. And then using code that we've written into the Arduino board, we told it to come out here through each of these digital pins. So if I push, say, the right button on here, then the signal comes in through the joystick into the button that is, let's see, I think that one is about 4. No, yeah, it's 4 because it's +1. So it comes into pin 4, and the code tells it that that is assigned to button state 3, right here. And if that signal is activated, or as the code says high, it tells the angle to go positive 250, which basically means it's going to turn it to the right. If I'd pressed the left button, then it would have corresponded to button state 4, which is the same motor. It comes out of just 2 pins. Button 3 and 4 is assigned to the second servo pin, but it will turn to the left because it has a negative angle. So through this, we've basically assigned that each of these motors can like to draw simple shapes with an etch-a-sketch. Now, unfortunately, we couldn't get it to go diagonally, but you can still get some pretty simple shapes, and it's much more intuitive than using the original knobs that were on the old etch-sketches. And it's as simple as that.
Now a little more about the circuitry of our project. We have a 5-volt reference frame for each of the push button states, as well as 5 volts being incorporated into no, scratch that. It's just the 5 volts into the reference frame, which then goes from that reference frame, which is the black wire here, 5 volts going to the black wire, to these other output wires that correspond to the up, down, left, and right directions of the joystick. From here, again, we added resistors just for safety precautions in case the motors didn't have enough resistance in themselves, which then went from the resistors to common ground states. But in between the resistors and the input, essentially in parallel to the resistors, came our inputs into the Arduino board, which were then translated into outputs from our servos to our motors.
I'd just like to explain a little bit more about the digital input controller. It'll be found, this digital input system will be found in any average Atari controller, and you can actually build one yourself. It's actually quite easy. This thing just runs on a button system, and all you're doing is closing the circuit when you push down a button, and thus initiating motor transfer between this controller and this machine.
Again, this project was headed by David Thompson, Andy Hicks, and myself, Costin Rare.
One last thing I just remembered, just the last detail, all we did to mount these motors onto the etch-a-sketch, we removed the plastic knobs that were originally on there, and we had these motors which happened to have a hole that was about the right size for the metal rods that the plastic knobs fit in. So we just unscrewed this, and then Costin here had basically just took a knife to it and made it larger so it would fit down on there. Now when we did that, it was a bit too slick to really hold on, so all we did was add some super glue to give it more of a friction on the surface. We also
in between the motor and and the rod that
Yes.
controls the movement of the etch-a-sketch pen.
To mount these motors onto the etch-a-sketch, we just took some aluminum bars that we had cut, and we super glued them onto the board, the etch-a-sketch board that is, and to the actual motor, which had pre-existing holes. And then to give them extra support, we added this steel epoxy to there.
And that's about it.
That's it.